we're ready to add our boundary conditions. So let's turn off the user layers because we're kind of done with those layers. We're actually going to be working in this layer now, but we're going to be assigning an inflow condition to the beginning of the channel here. So I'm going to use the boundary editor, click create, and then click on the layer and click OK. That places a button right there. If I click save, actually I'm not going to click save, I'm just going to click the button again. That does the save action, and click yes. And now we need to add a new hydrograph to this point. So let's see. We can do one of two things. We can add the hydrograph that's in the file, or we can create a steady hydrograph. So first of all, let's set this to a channel, and then this becomes add inflow time series, and let's call this 500 CFS steady, and click OK. We have a little bit too much data, so we'll delete 2 lines of data. This goes to 0, this can go to 0.1, and this can go to 10. That's our simulation time. This can go to 500 and 500. Or you could ramp that up over an hour, or you could ramp it up in increments, like run it. This is actually a good idea. So like if you want to try to get up to closer to bank full, you can start at 0.1, and this can be 100, and then this can be 0. Let's say 0.5, and that can be 100, and then this will go up to 1, and that can be 250, and this will be 1.5. So we'll run each of these for half-hour increments, and then this can go up to 2, and this will be 350, and this can be 2.5 at 350, and this can go up to 3.5. And you're just doing increments, so you can step this up so that you can see how your hydraulic structure responds to it. So it's just a good way to, create your data. And then we go 4, and then I got about a 500 or 600 or 550, and then 4.5, 550, and as of course as we run this, there'll be also rainfall coming to this channel too. And then of course that 550 we can carry out to 10 hours, and that'll also be 550. So that's kind of how you use a stepped hydrograph, or a current discharge. Stepped hydrograph or a steady discharge, a steady hydrograph. You can set it up like that. Or you can add a new time series, and we'll call this one, well, let's see, I think we can just cancel. Let's see if we can. No, we don't want to. We don't want to import. We don't want to open inflow.dat. We definitely want to get this from the data. So in lesson 2 should be the 6-hour Greenway inflow. Control A, C, W means Control All select, Control C copy, Control W is close, and Control V is paste. I'm sorry, I don't know why this isn't automatically updating. It should be, but we'll get that sorted before we send this out. And then that will be Greenway in 100 year 6 hour. And then of course you can swap those out really quickly just by changing it to the one you want to run and then schematizing it. So you change it and then schematize it. So let's use this stepped hydrograph. And now we need to go to the other side of the channel and set the downstream boundary condition. That'll be this guy. So downstream boundary condition, we turn that on, click the button, or click the very last node and click OK, and then click that again to save it. You can name it. This will call Greenway out, and click OK, and we can set this to floodplain and channel outflow no hydrograph and schematize it. And this will, what is that button? Oh, delete schematized data. Yeah, that'll delete your schematized data. If you mess something up, you can delete your schematized data. Now this will allow you to run, so any water that comes down into this channel is going to leave this boundary as a sink at a normal depth discharge. The outflow condition is assigned to the whole cross section, not just this grid element. That's why it's assigned to channel. Same on the inlet condition. This water will enter from this cross section, and it will stay in the cross section until it overtops the channel, which I'm sure this can contain more than 550 CFS, so it shouldn't overtop the channel. And it will also get rainfall data in addition to that inflow hydrograph. Okay, so let's save. I don't think actually we don't need to save. Let's export it. We don't need to turn on any switches for the outflow conditions. They just have to exist. So let's export it. Oh, wrong button. And take a look at what we've exported. So I'll do, actually I am going to delete it this time because I don't want a bunch of junk in there. And then save, and then it finishes that, and that is what it exported. So let's take a look at what we have done, the new data that we've added. So we have a change here. We've added these and this and this. Okay, so com.dat, the only thing that changed is that we added this, this channel switch, and I told you that switch also changed. Inflow.dat, we have our F line from our basin, but we also now have our stepped hydrograph from our channel, and it is assigned to that channel node. That's a left bank node, but it's assigned to the cross section. And it's not a diversion, it's an inflow. Your outflow is very simple. It's just a K line to represent the channel, and then if anything overtops the channel and gets onto the bank, it'll also be treated as an outflow condition, which in this case that's not going to happen, so the K line would be fine in this case. The K means channel, O means floodplain. And then you saw in the previous RAS export, you saw these files already, but let's go over them again in case you didn't do the RAS export. So we'll pop this one over on this side, and this one stays here. So these are your control lines. You get one for every new channel segment. So see, so we should have 3 of those control lines because we have 3 channel segments. You get a single cross section for every N-type channel, and they should be in order in both files from upstream to downstream. This cross section 1 is cross-referencing to this one right here, and this X dash means that this is a sampled cross section, and this non-X, the fact that there's not an X dash here, means that this is an interpolated cross section. And you should see that we should have like 200 and so of these guys, 268 and 268. Over here, this is grid element number, roughness, and the channel length. An advanced lesson will cover how to set the roughness. Chanbank.dat is just left bank, right bank. That's all that is. So those 3 are done. And that's it. That's all the new data. So let's go ahead and run this and we'll just let it finish while we're waiting to prepare the next video. So we just come here and click Run Flow2D, and what you should see is that as soon as it starts running, it's going to fill all this data. See, starts running, and it didn't get any errors, or else you wouldn't see this. So we'll minimize that, let it run, and then when we come back at the end of the next video, the run should be finished. So the next thing to do will be to add our hydraulic structures.